Hi everyone, welcome back. In this video I will explain how we can now minimize the loss function. So recall from last video that we defined the loss function, which maps every tuple m of q, which are the weights of the function that tell you which line do we actually want. Do we want this line, do we want this line, or this line? So this is our loss. We want to minimize this. Now, how can we do this? We will use a term which is called gradient descent. And let me explain you what happens if we are just working with functions in one variable. So let's say a function from r to r, which goes like this. Of course, we see here that the function is minimized in this point, so we actually want to go here. But if we start, for example, here, then of course we want to actually move to the right, because we know in order to minimize, we actually have to increase our x value. If we are here, then we have to go to the left. Now, if you would draw the tangent lines, because the slopes of it, they are actually, it's the derivative of the function. Like in this point, we see that f prime of x is actually smaller than 0 because we have a descending line. And here we have an ascending line, and so our derivative is actually bigger than 0. So in both cases, what can we actually do if we go from x and we subtract f prime of x? Then we move in the right, not from left and right, but in the correct direction to where the minimum is obtained by the function. Of course, this is something for functions from one variable. Remember that, and we will see another example in a few videos time where we will have lots of input variables. What we can do is, so we have, let's say we have m subscript 0 and q0. We calculate the loss m0 and q0, evaluating this big function L here. But then we are going to update our function weights m and q. And how are we going to do this? Well, very easy. We're going to make m1 equal to the old one minus the coefficient eta, which I will explain just in a bit, times the partial derivative of this function L in the m direction, evaluated in the point m0, q0, and q will be updated to q0 minus the same eta, and now the partial derivative, of course, in the q direction of m0 and q0. Why this minus? This is exactly from the one variable case to go towards the minimum. And what is this eta? This is what is called the learning rate. It says how fast a model actually learns. Typically this eta is around 0.1. But this is what we call a hyperparameter of a machine learning model, and this is often something one has to experiment with. One tries different values of eta, because sometimes using a too high learning rate will overshoot, or picking a too small one, it takes a lot of time and maybe there's not enough training data. In the next video, I will make a summary of the entire flow, what happens, and then we're gonna construct our own machine learning model. Ciao!